Hello and welcome to Mathematical Coaching Center. Today in this video we'll be proving one theorem related to angles in a circle, and this is the third theorem that we are doing. And if you have not seen the first two theorems, the link will be given in the description. But before we begin, my name is Umang Khawas, and if you have any problem in learning mathematics, then consider subscribing this channel. So without any further ado, let's start. So let's first see the statement of the theorem. The statement of the theorem states that the angles in a semicircle is a right angle. So if we are able to draw an angle in a semicircle, then it will be equal to right angle or 90°. So if there is a circle with center O, and if AB is the diameter, so drawing AB a diameter, this divides a circle into two equal halves, that is the semicircle. Okay, this is one semicircle and this part is the next semicircle. Now if we draw an angle on the taking any point C, so if you draw this angle here, we get an angle here, so this angle will be equals to 90°. So this is the ACB, is the angle at the semicircle, and that has to be equal to 90°. So this is what the statement of this theorem states. So to prove this theorem, we will be using one result of a theorem. So the statement says that the angle subtended by an arc of a circle at the center is double the angle subtended by it at any point on the remaining part of the circle. So if there is a circle and we take a small arc AB, and if we draw the angle at the center by joining the points, okay, so this is the angle at the center. Now on the remaining part, okay, this is the remaining part, this was the arc and we are drawing an angle at the center. So in the remaining part, if we choose one point C and join AB with C and get an angle like this, okay, this is the angle at the remaining part of the circle, and this is on the remaining part, this is also a point C, and we join this line here. Then the angle formed at the center, that is this angle here, okay, this is the angle at the center, will be double the angle at the remaining part of the circle. So this is the angle on the remaining part of the circle, so this is the angle in the remaining part of the circle. So we can write angle AOB, that is angle at center, is twice 2 into angle ACB, that is angle at the remaining part of the circle. So this is an important result. This theorem is also proved. If you have not seen or gone through that proof, the link will be given in the description. Now using this result, let's try to solve a theorem, that is angle in a semicircle is a right angle. Now here I see that AB is a diameter, O is the center, and ACB is the angle in the semicircle. So these are the things that we need to write in given. So given in a circle with center O, angle ACB is the angle in the semicircle. And what are we supposed to prove? That this angle ACB will be equal to right angle, that is 90°. So required to prove that angle ACB is equals to 90°. Now let's move on to the proof. Okay, so proof is simple. So as I can see that this, if I take this part as an arc AB, I see that angle ACB is the angle at the circle, okay, and this angle here, if we can draw an angle here, this will be angle at the center. So the angle AOB is the angle at the center, and angle ACB is the angle on the circle on the same arc AB. If I'm considering this as an arc, the lower part as an arc, I can see that I can draw an angle here, okay, so this will be the angle at the remaining part of the circle, and this is the angle subtended at the center. So this is the angle subtended at the center, and this angle here is the angle at the remaining part of the circle. Now by the result that we know, angle AOB will be twice angle ACB. Okay, so now again we know that AB is a diameter, is a line segment. So I can if AB is a line segment, then what will be the measurement of angle AOB? It will be a straight angle. this is a straight angle, and angle AOB, if it is a straight angle, it will be 2 right angle or 180 degree. So the measurement of angle AOB is 2 right angle, but we have that angle AOB is nothing but it is twice angle ACB. Okay, so comparing this to what we get is 2 angle ACB will be equals to 2 right angle. So after cancelling this 2 and 2, I get angle ACB is 1 right angle. That is, the angle at the semicircle is 1 right angle, that is 90 degree. So angle ACB is 1 right angle, or you can say angle ACB is 90 degree. So this is how we prove this theorem. I hope that this video was helpful for you in understanding the proof of the theorem. And if you have not subscribed to this channel yet, do subscribe to the channel and turn on the notification bell. So thank you for watching and have a very good day.